Welcome to Oracle Virtual Developer Day. My name is Frank Nimphius and I'm from the Oracle JDeveloper and ADF Product Management team. In this session, I talk about best practices for real ADF projects. Intentionally, we put this session into the advanced track as it requires you to have a basic understanding of the technology and terminology that we use in Oracle IDF. For the agenda, I broke up this topic into 7 categories. I will talk about how you can simplify your development choice and then go by technology stack, business components, task flows, bindings and phases to present best practices on all areas. I have a brief talk about JavaScript and then you will learn what I mean by breaking out of isolation. Oracle IDF is a very powerful framework and there's a lot of technology in this framework. Developers look for ways to shorten the choice for Oracle IDF applications, and here is one way of doing this. If we categorize developers based on their development experience, then we can categorize them in database-oriented development, Java EE-oriented development, or SOA-oriented development. If you come with a database development background, probably you're really good in RDBMS, PL SQL, and ADF Business Components as a business service in ADF is as close as it gets to what you experienced in previous development projects, maybe using Oracle Forms. If you have an EGB background, because you're a Java EE developer, then you do have an object model that you want to build ADF applications on. If you come from a SOA end, then everything in your universe is a service, be it a small isolated service or if it's a composite service. So everything kind of is constructed in a service. Now, all of these 3 developers or developer types will build ADF applications. And if we look at what's now in the dark gray shaded area, then all of the 3 developer types use the same set of technologies to build the application, which is the binding layer, the task flow, ADF phases, and the data visualization components that we use to render graphs. The difference on all of these 3 stacks is what you use as a business service. And here you would use what your skill set is the closest to. On the database-oriented side, you would use ADF Business Components. On Java EE, you would use EGB GPA. And if you're a SOA guy, then you use services. If you need to reach out to a different technology, like the database-oriented developer needs to reach out to include a web service, or the EGB developer needs to include the web service, or the SOA developer needs to include PL SQL calls, then you should look into the business service that you're working with, how to do it. This way, you provide the same and consistent API between the business service and the application developer. And the application developer, through the data control, will still work with ADF bindings, task flow, ADF phases, and data visualization. They don't need to bother about the technology that you use as a back-end side. So this is the simplified of your technology choice. Just start from the back-end and then work upwards to the application layer. So let's have a look at ADF Business Components. ADF Business Components is a metadata framework. It's a persistent framework that is built by Oracle. It's equivalent to the use of EGBs, though not exactly the same. As you can see from the image, it has XML definitions that at design time developers create to describe an object. Entity objects, for instance, map to a table, and you use entity objects to insert, update, and delete on a table. At runtime, all the metadata that you develop at design time will be passed and interpreted by Java objects. And these Java objects come with the ADF Business Components framework. And we will see later how you can extend the behavior or change the behavior of the default framework according to your needs. So just to finish this screenshot here, entities are accessed through view objects, and view objects have normal, regular SQL queries that query the data from the table that the entity object is bound to. A view object can be bound to many entity objects. I would think that 80% of all the cases is where you have a one-to-one mapping, where one view object that just looks to one entity object. And then the view object is exposed on the application module, which holds the transaction and exposes the data model, which then through the data control is exposed to the application developer. So for the best practice, I do have best practices to share on the architecture level and on the implementation level. So let's start with the architecture level. When you go to the JDeveloper preferences, then there is a node for ADF business components that allow you to change some of the default settings that the framework has. And changing it in the IDE will make sure that whenever you create a business component, be it an entity or a view object, these custom settings will be applied automatically. So one of the changes, and I already mentioned this, is the base class. Now base classes are used by the framework to interpret the XML at runtime. Here what we can see is that the base class names are entity cache, entity impl cache, entity def impl, view object impl, and they all reside in the Oracle JBO server package. The recommendation is that at least you create a custom version of the application module impl, entity impl, view row impl, and the view object impl class. Even if you don't have anything to say, just create an empty version of that. And this empty version should extend the Oracle default framework classes. And from then on, your classes, once you configure them in the preferences dialog, as shown here, your classes will be used at runtime to pass the design time. Why would you want to do this? Well, one reason is change. Right now, when you start building ADF business components, you just go with the default behavior. But to some time, you might want to change the behavior. You want to add, for instance, logging or auditing. Now, instead of just going to every view object or entity object or application module that you build, you just change your base class. And because your base class is used with all view objects, automatically that will be implemented then on all of the entities, view objects, and application modules. There's less a reason for doing the same for def classes. Def classes describe an object and the attributes and all this kind of stuff. One of the use cases where you would create a custom base class would be if you want to have a parameterized entity or view object. But this is fairly advanced topics here and is well documented, so you want to look up for that. Another change is the packaging structure. By default, all of the ADFbc objects are written to the standard package structure that you create, meaning they're all in the same folder. With a very big business service model, that could be quite irritating if you have all of the objects just mixed in one package. So you can create subfolders or sub-packages. Like on this screenshot, all entities should go into an entities subpackage. All associations should go into a folder ASSOC, view objects in views. You can also decide to have entities having a subpackage which holds the associations, the links between entities, and for this you would just put in entities.asssoc as you see it on the screenshot here, so that association become a subfolder of that. And this helps you to structure your model so that everyone has it easy to read and to find objects. There's a site that we set up for all kinds of architecture topics. It's called the ADF Architecture Square. If you go there, you find video recordings referenced for overall architecture topics, but you also find code guidelines and naming guidelines and naming conventions. And naming conventions is really important to have when working with metadata frameworks like Oracle IDF to avoid conflicts with metadata. Remember, everything, not only in ADFbc, is driven out of metadata. So reason enough to make sure that the naming guideline ensures no conflicts. On the implementation best practice, a recommendation to share is not to create impl file for all the view objects that you create. And I'm not talking about the base classes. I'm talking about creating view object and entity object and application module impl classes for all of your application modules, view objects or entities. Some customers argue that having impl files makes it easy to debug code, and I agree. However, if you create files for no use or for no reason, then basically all that you do is you blur your code line. So that is kind of messing up the whole manageable code that you create. So recommendation clearly is only create impl files when you really need them. If you want to debug, create an impl file, debug your application, delete the impl file. If you use Groovy, for instance, then having an impl file on a view object gives you a more or finer grained access to methods contained in a view object, which might not necessarily be exposed to Groovy that way. So if you decide to go for Groovy, then having an impl file could be quite of good help. Otherwise, don't generate impl classes unless you have a need. When we create view objects, then the view object is a blueprint of a query. The recommendation is not to create view objects for all different filter conditions like where clauses, but instead just use view criteria, which are named where clauses that could either be programmatically applied to a view object or by editing on the application module level, where on the view object instance you can associate a view criteria with a view object. Use bind variables in your view criteria queries because that makes it easier for the database to remember the passed statement and it doesn't need to repass the statement over and over again. Be aware of the option to ignore null values. While this looks like tempting to, for instance, run a query without filtering and later on have the user filtering it, keep in mind that ignoring null values could lead to very long fetches from the database. So a lot of data that you will query and you might not need the data, and for that reason try to ignore null values in that you ignore it. Don't select the box that ignores the null value. There is an API in ADF Business Components to dynamically set a where clause. Don't use that because it will require reparsing on the database side. And second, if you allow users to type in a where clause condition and you just append it, you risk SQL injection attacks. So always go with view criteria, always go with bind variables, and if you can't, at least use bind variables. Developers always strive for better, and they are instantly, as soon as they start working with a framework, they don't trust the framework and they tend to tune the framework. And if that is without reason, if they're not experiencing a problem, then that falls under the category of premature optimization, and that typically is a waste of your time and a waste of your resource. If you have doubt about performance, measure it. If you can measure a problem area, it's easier for you to identify what needs to be done and then look for optimizations. First of all, makes the assumption that ADF probably will do it right and that doing it yourself, controlling it yourself, most likely opens a can of worms instead of really doing anything better than what the framework by default does. When you design application modules, think application module pools. So that is an application module, if it's requested, will serve a specific call and then it will be handed over to the application module pool. This way, we don't have a one-to-one association between a user requesting a functionality and the application module serving it. And you can, as a rule of thumb, think about having one application module instance serving 10 to 15 users. So if you want to look for sizing information, just cut down the number of users you have by 10 or by 15, and then you have an idea of what the application module setting should be for the pool. All of the configuration settings are accessible on the application module level. There's a pooling and scalability section. However, read, understand, and then tune, and not the other way around. The tuning in general is well documented in the Oracle documentation for 11G and for 12C. Read this, see what the different options provide, and then play with the options if you measure or experience performance problems. Don't tune without a need. Switching topic here, now we talk about the task flows. And again, for task flows, I do have a section on architecture and one on implementation. Now for architecture, first of all, let's have a look what we can do within the task flow. A task flow has a communication API, which is input parameters and return values. And within the task flow, you have a flow, and that flow allows you to just navigate between activities. If you want to leave a task flow, you have a return activity. Task flows can have their own managed beans, and you should use managed beans only defined within the bounded task flow. Don't try to cross or define a managed bean that crosses multiple bounded task flows. And task flows, as indicated by the database here, can run in their own isolated transactions. So it's a key element of ADF development, and one of the reasons why whatever you do, you make sure that you think task flow, because task flow is a key unit of work that you actually use to build applications. So from an architecture perspective, think task flow oriented. Think task flow from design time on. Look for existing task flows and how you can reuse them. Identify patterns and standardize on this task flow. Like a pattern would be error handling. Make sure they all have the same level of error handling and the same quality of error handling. Make sure that you use a task flow template, for instance, to predefine managed beans that provide a default functionality that you use across the board so that you have a consistent functionality in your task flows. Ensure that the objectives and requirements that you have reflect all of what task flow can give you, starting from reuse to loose coupling. If there is a use case that you can design as a task flow, and if there's a chance that this can be reused, then make sure that by design you always work through input parameter and return values. Don't make any assumptions. This is what the loose coupling then will give you, that you can use the task flow in different applications, even across the applications. Think about a task flow as a unit of work, like a use case that you can write that could be represented by a task flow. If a task flow becomes too big, don't hesitate and break it up into subflows. And you can, on the task flow property, even hide a task flow from showing in the resource palette to make it an implementation detail. A shared data control makes a lot of sense if you have subflows. So if a task flow consists of many different subflows, then sharing the data control is the most performant implementation that you can have. Plus, it will make sure that data state is passed on to the different flows. And then hide the subflows from the ADF library so that the one entry point of this unit of work is displayed there. And that's a property on the task flows. For the sizing, there's no rule for the task flow. You can build very large task flows or you can build small task flows. The large task flows will probably have resource impact in that, for instance, objects that you save in memory will be held much longer, or if you have a separate database transaction, that separate database transaction will leads into a separate database connection will live longer than in a small task flow. If you have a too small task flow, there's a lot of management and administration around it, especially in terms of maintenance and just putting it to the next level if you upgrade the application. So probably best is to meet in the middle and identify task flows that could live as composites, identify task flow that provides some kind of standalone functionality. Typically, it makes sense to think like SOA, like service-oriented architecture. What is the service doing there? And then try to map this to the use of task flows. For the task flow implementation, one of the best practices is to handle input and return parameter values in managed beans. Every bounded task flow can have managed beans. If you just have at least one managed bean that you define through a task flow template in page flow scope, then every input parameter could be mapped to this managed bean, to a property in that managed bean. The benefit you get out of this is documentation. If the input parameter doesn't speak for itself. You can document in the managed bean what the parameter is providing. You have a type-safe API because the method that you're talking to will expect a specific data type. You will have it expression language accessible. Now imagine you have a longer task flow, and this longer task flow might be developed by you in the beginning, but then at the end someone else will take over. Now how would they know what a specific input parameter value is named in the memory scope if you're not using a managed bean? So it's easier to discover. And you have a null pointer protection, because if an input parameter is optional but you rely on it to be existing, then you can check that in the managed bean and either provide a default value or just do whatever makes sense in the context of the application. So always save input parameters and return parameter values in managed beans. Don't write them straight to a memory attribute. A managed bean in Oracle IDF, and we do have managed beans in Java surfaces as well, are Java classes that are fully handled by the framework. In ADF controller, you can configure managed bean in the ADFC config file, which is the unbounded task flow, or in the task flow specific files. Recommendation is put managed beans always into that task flow file where the managed bean is used. Don't make any assumption that probably a managed bean in a longer scope could just cross the task flow boundary. Always think loose coupling. For this, you should use ADF controller specific scopes only, and this is backing bean scope, which has a length of a request, the view scope, which is there for as long as a specific view, and that could be a page fragment in a region lives, or page flow, which lives for as long as the task flow is. Managed beans should never hold data specific logic, only UI related logic, complex UI related logic. So bounded task flows and managed beans. If you use managed beans, make sure that you use the smallest possible scope. So I talked about the three scopes: backing bean scope, view scope, and page flow scope. Always think, is there a need for a managed bean to hold state? If, for instance, a list of value or a select many box writes information, selected values into a managed bean, then yes, this bean holds state. So at least that should be then in view scope or in page flow scope. However, if it's just calling a function, then it's not holding any state. No information needs to be remembered. So you want to put this into backing bean scope. The smaller the scope is, the earlier the framework will clean up all the resources that you allocate. Don't reference managed beans in a session or application scope. If you want to keep with the task flow paradigm of isolation, of reuse and loose coupling, then only use backing bean scope, view scope, and page flow scope. Never make assumptions about any information existing in the session or the application scope. If there is information in the session that you need, just provide this as an input to an input parameter in a task flow. The data control scope is one of the settings. You can have isolated or shared. Shared is, from a performance perspective, the best option for you to use, because that makes sure that only one single database connection is used. If you're using ADFbc, if you use EGB, then only one instance of a specific session bean is instantiated. If you need to have a separate transaction in ADF, you set it to isolated in the ADF business component sense. This then means that you open up a new transaction and a new database connection, which means that a user potentially could have many database connections, and you want to avoid that for performance reasons. So be very sensitive about when to use an isolated data control scope and go by default with shared data control scopes. Every task flow should have an exception handler, and that is an activity, like here a method activity, that you select, and then you click on this red icon there to identify this as the exception handler. You want to create a task flow template that holds the exception handler and the exception handler logic to make sure that all bounded task flows handle exceptions. The reason you want to do this is, remember, if you go from one task flow to a subflow to a subflow to a subflow and so on, and if there is an exception that's not handled right where the exception occurs, you take the user out of the working context. And how would the user remember what he/she did wrong when you have to step back 3-4 levels deep just to get to the same situation. So always have exception handling in the bounded task flow. For ADF binding, we need to be clear of what ADF binding really is. Well, the binding layer in ADF replaces the component model. When you're building Java Server Faces application without ADF, then you would build the component model as a managed bean, which is quite some work to do. The binding layer hooks into this. It's a generic binding layer, which means that we have a consistent set of APIs that you always work with. We have specific bindings for trees, for tables, for input text fields, for graphs, and so on. They hook into the component model and provide the information. And you see there are two binding classes involved. One is a generic binding, and one is a specific binding to a specific component technology, like for instance in ADF Faces. And typically the component-specific implementation is private, though they're not private classes, but you shouldn't use that. You should just go with the public classes. The binding layer exposes methods, collections, and attributes, and can be accessed in expression language or Java. When you use expression language, you can use the hash binding stack, or you can use the dollar bindings. Both will provide you access to the binding layer. The hash is used in Java Server Faces pages, whereas the dollar is an immediate binding at compile time, is used in the binding layer itself. For instance, for a method to reference a binding to provide argument values. From Java, the entry point always is binding context.getCurrent, and then there are methods like getCurrentBindings entry, which will give you in Java the direct access to the binding container for the current page that you're looking at, or the current page fragment. Input parameters, if we look at the expression language here in a page, so like input text fields, will have a reference to the bindings layer like hash bindings first name input value, whereas in the page dev file the same would be possible to do with a $sign. Use public APIs only. As I mentioned, the faces control classes, for instance, are non-public APIs. Though they're public classes, and if you use them, meanwhile the IDE will flag this as a warning, but still would not complain compiling it. But we recommend not to use that. They are internal, and all of the internal classes have the name internal in their package structure, and this definitely is a clue. So don't use public APIs, because that will haunt you later. If there's anything you cannot find in a public API, you have two options, maybe three. One option is to go to customer support and request an enhancement to provide a public API for something that you so far find internally. The second option is use expression language in Java. You can have a value or a method expression that you can use in Java, and then you provide the same expression language string that you, for instance, see on a table selection listener, like what's on the slide here. And the third option is to use the OTN forum and post it as a question for some people to help you with the code. When you have to access business service methods, always expose these through the binding layer. So if there is a method exposed on a view object, like relocate employees, that takes a set of employees, never go straight to it, always go through the binding layer. Because if you don't do that, if you don't work through the binding layer, then the binding layer will not know about the current state of the business service, which means that if you're not actively requerying the business service, the data you see in your ADF view is not the same data state that is in the business service. So always work through the binding layer. Call methods through the binding layer. The second argument why you want to do this is error handling, because all errors that happen on the business service will propagate up to the binding layer if they're accessed through the binding layer. So if you don't do that, then the exception will maybe throw you to the browser. So you don't want to do this. So always work through the binding layer and make sure that if there's a data-centric method, you always have that exposed on the ADF business components and then exposed through the binding layer. Here's an example. So I have my business service model there and the view object or the application module has an impl file that exposes a method like here, invoke PL/SQL. Then on the binding layer, I create a method binding and I have two options here. I could drag and drop from the data control palette or go to the page definition file to the editor and use the green plus icon on the binding section to create that method binding. Similar for attribute bindings. If, for instance, my method requires an argument, then I automatically can create a parameter form. I just drag and drop that in, and then it will create an attribute binding that could either be called from a managed bean or directly called from a page. Everything that you see in the page.def file will at runtime be part of the binding container, and for that reason can be accessed from Java or from expression language. And here on the left hand side, the text and the button clearly would use expression language to hook up to the method binding or to the attribute binding. I mentioned the error handling, and there's a central place which is in the data binding CPX, where you can specify a default error handler, replacing the current framework-owned error handler that we use by default. For this, you go to the data binding CPX file, and I have a screenshot on the next slide, and you create your own error handler by extending the DC error handler impl file that we provide with the product. Now, the DC error handler impl file has methods like report exception, get display message, get detailed display message, and skip exceptions, which you can use to manipulate, first of all, which exceptions are reported and how they are reported. You can add, for instance, HTML, or you can just suppress a method by just returning a null value, so it's not really displaying for the user, still giving you the hook points to perform all kind of logging, incident reporting. Some errors are so bad that you want to send off an email to someone who is administrator just to look at the system. And this is all what you can do in the error handler. So the error handler is a very important part. And here is the screenshots. So within a project, you go to your data binding CPX file, and then you select in the structure window the data bindings node, and you can see the error handler class here is specified to the full package name and class name of the error handler that I created here. The error handler must be set, if you want to use a custom error handler, on the assembling application, so on the deployable application, not on the task flows, not on the model layer, just on the deployed application, the view application that assembles all of the task flows. ADF phases. Here it's important to talk about backing beans. Backing beans are special users of managed beans. They contain UI component references. You can have component reference to a backing bean so that within your code, like a value change list, you can access that component, refresh it, or manipulate it differently. All component references that you have in the binding section must be in a request scope, or if you go with the Oracle scopes as recommended, in backing bean scope. And the reason is that Java Surface components are not serializable. So you don't want to pin the component, and not to pin the component, you use the component binding in a request scope length. Best practice, however, is to avoid backing beans altogether. If there is just like a reason for you that you want to reference a component like a rich input text field, then you can dynamically look up that component from the view root, just calling faces content, get current instance, get view root, and then find component by its ID. Of course, considering naming containers. You can have a relative search, so if I press a button and that button has an action event, then within an action listener I can call get UI component and have a handle now to the button, and from there I can call find component for all of the components that are relative to that button. Or you use the Apache MyFaces Trinidad component utils class, which has a find relative component method as well, which is performance optimized and a good recommendation to use instead of component bindings. When you use backing beans, make sure that beans never extend the request length, and that if you use a backing bean of two consecutive views that they use different classes, because if a backing bean reference is in request scope, it goes from one view to the next. So that means it's not released to the time the another view is rendered. So if they share the same bean class, then also you will have unpredicted results. So always make sure if there are two views that both use backing beans, that those beans have different classes. They have separate instances. Avoid expression language gotchas. The question is, do you need to prefix or not prefix expression language? Here, everything that is in the normal servlet scope, like request, session, application, or no scope, which is also an alternative, is going without a prefix. So you're not doing session scope dot bname dot property. You just use bname dot property. If you prefix a servlet scope with a scope, then it will look up in the memory and it will not create the managed bean. So whenever you see an issue with a managed bean, null pointer exceptions once in a while, probably you prefix the bean. However, prefixing the bean is required if you use the ADF scopes. So we need to have, for instance, backing bean scope dot bname dot property or view scope dot bname dot property, because here the bean is managed by the ADF controller. Recommendation of best practice, always go with the Oracle scopes, which means in this case it's safe to always prefix. Makes it easy to read and puts you on the safe side. So try to avoid in your ADF applications the servlet scopes, request, session, and application, and you should be fine. Just put that into your developer guidelines and you shouldn't hit any problem. Don't use HTML, though constantly Java Surfaces is going to improve, and they're trying to close the gap between HTML, JSP, and Java Surface in terms of how they compile in the life cycle. Still, it's not a good choice to use HTML in the mix with Java Surfaces components, especially not if you use ADF Faces. The reason is that ADF Faces components try to manage the available screen, so we call it geometry management. Now, if you put HTML in there, then HTML will take some space of the screen that Java Server Faces and ADF Faces is not aware of. Recommendation clearly is, when you build pages and page fragments, always use ADF Faces components. Just go with this one-hand approach, where one hand just provides you with all the components to build your application. Avoid includes. If you use JSP includes or UI includes, only because you used to do that in Java Server Faces programming and JSP programming, be aware that in ADF, the page is associated with a binding layer. And if you have an ADF-bound page fragment that you include through UI include or JSP include, then this binding layer reference is missing. So either you copy all of the binding information into the parent page that kind of consumes the page fragment, or you use task flows and regions, in which case you don't need to worry about the binding. Inline style and content style allow you to CSS style your UI component. Recommendation, however, is to use skinning. ADF skins allow you to have a fine-grained control over the different areas of a component, an input text field or a table. It has a lot of options and elements that you can work with. Inline style and content style both just work on the top level DOM, which could be a div object in the rendered outcome. So if you want to build consistent layouts, don't rely on the inline style and content style. There are good candidates for like conditional color coding. If you have data-driven color codings, like flag all accounts that are in the negatives as a red background, then that is what you can use inline style. Beside of that, learn to love skinning, and we do have the visual skin editor that helps you to build skins easily. I mentioned just a brief excursus on JavaScript. Well, we do have a JavaScript client API, and we do have a server side and a client side in ADF Faces. And it's well documented. If you use that client side, then JavaScript, of course, is good to use. However, still use JavaScript by exception. Reason is, everything that is metadata and everything that you write with ADF means is something that we can move forward to the next release. Even if there are changes, if there are component changes, binding changes, we can change that. We can migrate that for you with the next release. If you use JavaScript, however, then we have no control over your JavaScript. We don't even know where the JavaScript is, to be honest. So for ease of upgrade and migration, make JavaScript an exception. Also, always look for the solution to a problem first in ADF phases. And the reason is that if you do this in ADF phases, then the client side, which is the browser, and the server side, which is the view, the component, they are synchronized. So we make sure that there's some synchronization happening between the client and the server. Always put your JavaScript into external files so that they are cached by the browser, and use the AF resource tag to reference the files. Code against the ADF phases component model and not the browser DOM. So that is, if you look into Firefox, don't code against the div or the page areas or the table HTML components, as we know that we could, because ADF phases is component oriented, which is a huge difference to markup oriented. And as we will see, for instance, between 11 and 12, we're changing the rendering of HTML components, for instance, from dynamic HTML to HTML5. Now, if you use JavaScript with the ADF phases client API, then your application continue working. If you code against the DOM, your JavaScript might break. So make sure that you don't use JavaScript without a pure need. Also, like with the ADF classes, there in the JavaScript, there's a package naming, and the package naming has the name internal in it. If you see something in there, don't use it. On the JavaScript docs that we publish on the internet, you will see a very big red rectangle telling you that the class you're looking at is internal and private. So that was all of the content topics I had for this session. Now there's one last which I really want you to follow, and that is breaking out of your own isolation. Everyone starts to some point with a technology and is new, is so new that they don't know what to do, where to start, and they feel alone. So that is what I reference as the isolation. You feel isolated. Only you have this problem, no one else in the world. Now, that doesn't put a good mood on you. So join a community. Make sure that you're part of it. Make sure that you're visible. Make sure that you participate. And there are two communities that you really want to look at. One is the OTN forum. The OTN forum basically helps you with coding problems, helps you with understanding, helps you with the technology. Best practice is articulate your question as good as you can. And as good as you can doesn't mean just go long. Just go precise, just to the point. Think about what is the information that you would need to answer the question, and then put that in your question. Always take the same time to formulate a question that you will hope for someone answering the question to spend. Keep the questions really short but comprehensive, and always mention the developer version, the ADF version, the technology that you use, the browser, very important. If there's something that doesn't work as you would expect, make sure you test different browsers like Internet Explorer and Firefox, just to give whoever helps you out the guidance that they know that this is something browser specific. Google is a good way to start searching the OTN forum. Just type in the keywords of your question and see if you find hints within the blog sphere or within OTN. And as we've seen with many users of OTN, of the OTN forum, they all start asking questions. There are no stupid questions, I promise. The only stupid question is the one that you didn't ask. After a while, try to contribute. Nobody is slapping your fingers for a wrong answer. Contribute, because you will see that contributing, just answering questions, is exercising. Even if you don't have the problem, if you can help solving the problem, you will never forget. And the other forum is EMG, which is the Google group, which is independent from Oracle. And they talk about the full picture, the big picture, architecture, integration, concepts. They're not for anything flame and blame or technology problems, which you think might be bugs or missing features. They are just there for discussion about how do I do this? What is the best strategy to do something? And you definitely want to join that group, because all of the well-known customer experts and Oracle experts are on that forum. And last but not least, Schau Dich Schlau. Schau Dich Schlau, well, it's German, and what it means is make yourself a smart cookie by watching ADF Architecture TV. The ADF Architecture TV is a new channel that we started and that we hopefully complete all the sessions on by the end of 2013, that will then guide you through all challenges that you might have questions or wonder how to do in the course of a full ADF project, starting with team development questions, architectural patterns, code design, task flow design, how to design for transactions, security. There's a big recording on security, service integration, everything of interest. And typically those recordings are between 10 minutes and 50 minutes. So worthwhile just looking at it. And this is a YouTube channel you can subscribe to, so you get notification whenever there's something coming new. And once you watch them all, I can almost guarantee that you will be on the expert side. More community to join. The Twitter account, well, just join JDeveloper on Twitter, on Google+, on Facebook, and also the ADF Insider and ADF Architecture lessons and recordings that we provide, and they will keep on providing. There are more resources, e-courses, but you find links in the ADF Insider website that points you to everything. This concludes my talk about best practices, so I hope that proved to be useful for you, and I wish you a good virtual developer day.